So what's going on? Today we're back solving quadratic equations. Last time we solved quadratic equation using quadratic formula. Today we're going to take a different approach that will also get a solution every time, whether the solution is real or imaginary, also known as complex. The approach we're taking is completing the square. Completing the square. Now, we're talking about quadratic equations, so let's do a quick recap. Last time we referenced this thing as family. So this is our form. This is our family. We have my big sister here holding down the leading coefficient of A. I was holding down the leading with the middle term with B. And my rebel sister, my little sister, C student, right there. So right now, family is in order like it should be. Now, whenever we're talking about completing the square, we want to make sure that we have everything set up to complete the square, the proper form for completing the square. So whenever we're solving an equation, there's a few things we need to do. We need to let my sister, my younger sister, be the rebel that she is and go to the opposite side of the equal sign. And after she does that, we want to make sure that the leading coefficient that my oldest sister carries has a value of 1. So let's toss an example up here and put this to work. 15. Alright, so we're going to follow the process. The process says move C to the opposite side of the equal sign. Right now C is positive 15. How can we transfer positive 15 from this side to the other side? I'm waiting. Oh, you on it. You deduct 15. If you deduct 15 from one side, you deduct it from the other side to maintain equality. So now we have 5x squared minus 20x equals negative 15. Now you ask yourself, all right, you say, I'm doing completing the square. What is the next thing that I need to do? All right, I move C to the other side. I'm also supposed to make sure that A is equal 1. Oh, let me go check. A does not equal 1. So I'm going to go ahead. How can I make A equal to 1? I'm going to go to A and divide every term by the value of A. What is the value of A? The value of A is 5. So every term will get divided by the value of A. So now we have x squared minus 4x equals negative 3. All right, so we're going to go now and get into the whole completing the square process. The next thing you want to do, you want to take this B term, this new B term that you developed, and we're going to create a perfect square trinomial. Creating a perfect square trinomial, you have x squared minus 4x plus the B term, that B term, sign and everything, squared. If we put it on one side, we have to also put it on the other side. So we have negative 3 plus this exact same thing. The exact same thing. Where did this come from? The B term. It will always be over 2. And you will always square it. Follow? Cool. Alright, so now that we've created a perfect square trinomial, we're going to go ahead and simplify this. Simplifying, we have x squared minus 4x plus negative 2 squared equals negative 3 plus negative 2 squared. Cool. Let's go ahead and inch on over a little bit and move this guy on up. Whenever you bring this swing on around, boom, we have x squared minus 4x plus, when you square a negative, what happens when you square a negative? Negative times a negative gives you a positive. Killing it. Okay? Equals negative 3 plus 4. So as we simplify, we have x squared minus 4x plus 4 equals 1. Bust this guy down the middle. Factor this perfect square. This perfect square trinomial. You have, boom, perfect square trinomial. This is x minus 2 times x minus 2 equals 1. After we factor that perfect square trinomial, we see that anything times itself is a repeated product. So we can take this quantity, instead of saying x minus 2 times x minus 2, boom, squared equals 1. Now we'll apply let's term as the square root method. We want to undo this expression. And in doing so, if we want to undo this square power, we have to take the square root of each side. Equals plus or minus the square root of 1. This is magic, okay? So we have x minus 2 equals plus or minus 1. X minus 2 equals plus or minus 1. Solving for x, we're going to go ahead and add 2 to each side. And you have x equals 1 plus 2. 1, positive 1 plus 2 is 3. Negative 1 plus 2 is positive 1. You have your solutions to your quadratic equation. Now, that's all the steps, all right? Now, whenever you do a few examples, you start to pick up some tricks. So what I'm going to do, now that I've shown you all the steps, I'm going to show you this exact same example using my shortcut. Time to bring in drummer shortcut, drummer shortcut, give up that shortcut. All right, so check it. We already know that every time, boom, boom, go ahead and toss your square, equals, take that C, plus, boom, open up a small set of parentheses, toss up a square. Every time this is going to happen, every time you complete the square, once you achieve these two things, you move C to the opposite side of the equal sign. You divided, you made sure that A is equal to 1. This is going to happen every time. You take your variable, boom, your variable is X. You take this sign, boom. Then you're going to take this number, boom, divided by 2, boom. Go over here, take this same stuff, boom, boom. Following me? Following me? Again, I'm going to repeat it right quick. I open up a big set of parentheses, put on a square, took the variable, took this sign, took this number, over 2. Open up my little set of parentheses, put the exact same stuff in it. Watch what happens. We go ahead and fast forward through there. We have x minus 2 squared equals negative 3 plus, boom, negative 2 squared. I know, he killing it, he killing it. Come on over here. X minus 2 squared is equal to negative 3 plus 4, 1. We're at the end of the problem. Square root method. Come on through with it. Take the square root of each side. Undoing that squared power. Plus or minus the square root of 1. So we have x minus 2 equals plus or minus 1. Add 2 to each side. And we have x equals 1 plus 2, 3. Negative 1 plus 2, 1. Works every time. You're welcome. That's Drummer's shortcut. Drummer solve, completing the square quadratic equations. Drummer's out.